Hi, my name is Eduardo Ox. I'm the author of an Emacs package called EV, and the title of this video is 2 ways of creating .so's for Lua, one of them very fast, both using Emacs and EV. And remember that a .so is one thing that you can produce from a C file. For example, you can start with a C file like this one, and then compile it to a shared object, and then it can be dynamically loaded by other programs, for example, from Lua. Let me start by the very fast way of producing a .so, in which all the details are hidden. Suppose that I want to create a .so that defines a Lua function called -div, and the body of the Lua function is this thing here, these 3 lines here. We can run this epitch block here. Epitch is explained in this page, by the way. And we run it by typing F8 on each line. This thing here created a C file with lots of things besides the body of this function, and then compiled it using GCC, and then listed the the file is in the directory /tmp, this one, and the .so is here. And it also loaded this file, so now the function -div is available. And if we type F8 on this line here, it says that the result of running -div with the arguments 20 and 2 is 18 and 10. The details here are a bit boring. They are all in a file called clua1.lua that has an introduction, and then some templates, and then the programs that use those templates. And it also has some demos in test blocks. But it's better to start by this other way here, the way 1, in which everything is very explicit. Suppose that I want to create this file here. No, let me start from the point in which the file is already created. Let me open this file here. This is its code in C. This is the body, these 3 lines here. And somehow I created the rest of the C code. And this thing here is a test block, is something that I can execute with F8s, and that will compile the .c, the file in which I am, generate a .so, and test this .so. So let's run it here. Note that here we have 2 different blocks that define environment variables, this one and this one. If we execute them in order, then the second block will override the definitions from the second one. I'm on a Debian system, so that's what I want. But I have a friend who is testing this on Mac, and what he has to do is to run these 3 lines here and skip these other lines. Anyway, I want to run these lines here, and then this thing here. Now I have my file .c, my file .so, and now I can run Lua and ask Lua to load the .so and to run this function here to install the Lua functions that are defined in C in that file. And now the function -div is available and I can run it. Note that this thing tells loadlib to run a function with this name, and the function with this name is defined here. I'm sorry. And that function runs this line to install all the libraries listed in this table here, and one of these lines is an entry for a Lua function called -div, its C function, the C function that corresponds to it is this one, and it is defined here. So it's a bit boring to write a C file like this one, unless you do that all the time and you remember all the details. I don't. I don't use these things often, so for me it was much better to create some functions based on templates that would generate the files for me. Let me show how these functions work. If I run this function here, it creates a temporary buffer that will generate a file with this name here that defines a function like this. In the first moment, the function will be just a stub. We'll have to replace its body by something else. Let me start by running this. This is my temporary buffer. If I run this line, Emacs switches to C mode, so everything is much easier to understand because things have colors. And this line here will copy the rest of the file to the kill ring, and it will open this file here. Usually this file here is empty. Let me delete this file. So now I'm in a typical situation in which this file is empty. And if I run this thing here, then this function copy_rest copies the rest of this file to the kill ring. And now I can go to this buffer here, type Ctrl+Y, and I get my a copy of this thing. Now I need to replace this body here by something else. Let me delete it first. Let me go back. I'm going to use a copy of these lines here. And I also want to adjust my test. The test is this one. The test will be this one. And now let's test this thing. I need to execute this thing to compile the C file and to generate a .so. Here it is. Everything worked. And now I can run this Lua block here. It loads the .so and tests this function. So that's it. Let me go back to the very fast way. All these things are explained most of the documentation of EV is in sandboxed tutorials. The main one is this one here, and note that you can write anything here and do tests here, and this thing is in a temporary buffer. It's not saved in any file, so you can do any mess that you want here. And we have an intro called Lua tutorial. It's in a very preliminary stage, and at this moment it has most of its sections are about creating .so files, and it has one section for using clua1.lua from the inside, in the sense that I'm without internet here, so I can't run that demo now. But the idea is that we download 3 files in a subdirectory of /tmp, and we adjust 2 environment variables, one that tells Lua which file to use as an init file, and another one that says to Lua to add that directory to the path. And then the instructions will explain how to use this thing here from its test blocks. For example, this block here defines my main class, clua. And if we run this test block here, I will need a smaller font for a few minutes. It loads the current file. In this block here, I have to choose if I will compile on a Mac or on Debian. I will choose Debian. And now we have several tests that explain, that shows how the data structures work, how the things work in either in the lower level functions or in the higher level functions. And here we have some basic tests. And here we have some a higher level function that uses fewer arguments and that defines another way of creating a C file. And now we can run this. And in this block here, we can check that we can run build and load twice to define the function foo twice. And in the first time, the function foo will have this definition in which it returns this string or rig. And in the second time, we will redefine that function. The function foo will be redefined to be another function defined in C whose body is this, and that returns the string redefined. So we can use these blocks to test several definitions of a Lua function defined in C, and we can have a sequence of blocks like that one, and it's very easy to compare the results of running, for example, this and running this. And these lines here at the end just show some the templates corresponding to the last execution of build and load, so we can see what is the command for load lib, what would be the commands for require that I'm not using now. At this moment I'm using the lower level way of loading a C function. And what are the commands for compiling the C into a .so, and what is the code in C that is just this. So let me go back. This section of the tutorial explains how to use CLua 1. I mean, it explains how to download CLua 1 in the subdirectory of /tmp, and how to run the tests in CLua 1. And this other block here explains how to use the faster way from anywhere. Once we have CLua 1 installed in /tmp, I'm putting things in /tmp because I think that most people are just going to try this for 5 minutes. Very few people will make this more permanent, so it's better to put everything in /tmp. And this second block here can be run from anywhere. I'm not in /tmp now, and I can run this and create two definitions of the function -diff. The first one with this C body here, and the second one with this C body here, and each one has some tests. And that's it. I didn't explain everything in a lot of detail here because I guess that most people are going to prefer to read the textual instructions in this page, and I'm going to start working on that now. So this video is an introduction, and the precise instructions will be here. So that's it. Thanks.